So we're going to go ahead and we're going to start our neuroimaging chapter. And the first thing I want to talk about is I want to talk about why neuroimaging is such an important development in the field of psychology and why it's been so revolutionary. Right. So the first thing I want you guys to do is I want you guys to think about how we have talked in this class about how changes in the brain lead to changes in thoughts and behavior. Right? Can you think of any examples of how we have done research or the methods we have used to try to determine the relationship between the brain and behavior? So if you'd want to sort of pause this for a second and just try to think of some examples where we have made that connection. And so hopefully you were able to think of a couple examples. The main way that we have identified the relationship between brain and behavior and thought is through damage to the brain, right? Phineas Gage, who we talked about earlier in the term, with the bar going through his brain. Many of the case studies that you guys are working on right now all involve damage to the brain. And when specific structures are damaged, how does that affect the personality, the memory, the processing, the sensory perception of the person? And we then say that those specific areas of the brain must be responsible, those areas of the brain that were damaged must be responsible for the changes we see in the person. Right? Hopefully you guys can think of many problems with this methodology. Right? These are what we call case studies. These are single individuals. Right? There's a question is if I were to have a steel rod jammed through my brain right now, would I respond in the same way that Phineas Gage responded? Right? Maybe, maybe not. There are individual differences. There are things that can come into play, and it's very difficult to apply what we see in one person to human beings as a whole. So we're a lot more limited in that. Also, we can't ethically recreate these injuries, right? We can't just walk around with a ball-peen hammer and smacking people on the head wherever we want to test it. So if we want to test occipital lobe, we can't just bash the back of their head in, right? We have to wait for these injuries to occur. The injuries are not going to be consistent. They are going to be in different places. They will cover different regions of the brain. They won't be localized. So while useful, this is very limiting. Another way we could try is to do electrical recordings of the brain. Go in there and directly place electrodes in somebody's brain and either activate areas of the brain, turn off areas of the brain, or just do recordings of the brain. To do that, we have to remove people's skulls and stick electrodes in there. How are we going to do that, right? I can't just get a bunch of undergrad psychology majors to volunteer to have me take a hacksaw to their skull, poke some electrodes in there, and seal it up with super glue for a $20 Amazon gift card. I would assume most of you wouldn't want that. So when are we going to be able to do that, right? And if you think about it, there's probably only about one circumstance under which we'd be able to do it, and that's if we are opening up people's brains anyway. Right? And when do we do that? Well, we do that in surgeries. Most brain surgeries, the person is actually conscious. There is no pain receptors in the brain, so you just have to use localized anesthesia and a little bit of sedatives to keep the person relaxed, but they can stay active and aware through the whole surgery. In fact, this is often very important as they want to test certain areas of the brain to see, where they are, what they're doing, what effect they're having. You can have people often do language tasks or even complex tasks. Here is an example of somebody playing a guitar in the middle of brain surgery. So we actually have a lot of access to people's brain and their behaviors during these surgeries. And many times people will agree to allow some scientific experimentation to occur. Just last year, there's a fascinating study that used cellular recordings of the brain of people who were sleep deprived, where they're able to actually record the effects of sleep deprivation at a neuronal level, at a single neuron level. So this is one method, but it's going to face a lot of the same difficulties as the case studies, right? These are going to be only a handful of people. The circumstances are going to be very contrived, very limited, and applying this, externally validating this to other people is almost impossible. So what we really needed is we needed a method where we can non-invasively study the changes in biology of the brain and its effect on thought and behavior in a way that is quick, that is safe, and can be applied to large numbers of people. That's what we lacked. For the first 150 years of psychology, there wasn't a method to do this. But modern neuroimaging techniques allow us to bypass all of these issues we've talked about and directly look at the brain of healthy people, of controls, of any age group, and really get in there and begin to understand the specific biology and how it affects our behavior and our mental processing. And it was really the emergence of this neuroimaging technology that has truly brought neuroscience into the forefront of psychology and made it probably the most dominant perspective in modern psychology today. So our goal is going to be to break through some of the major methods that are used, what their pros and cons are, their strengths and weaknesses, and what exactly they are doing. So stay tuned.